This is our equation. After we get up to this far, what we can do is, we know z is 2 right here. Z is 2. Z is 2, we put it back. Y, 1 times y is just y. So y minus negative 2 times z. Z is 2. So put right here. Y minus 2 times 2 equals negative 1. That's actually negative 2 times 2 is negative 4. So y minus 4 is negative 1. Plus positive 4 on both sides. These two will be cancelled. So y is the only one on the left. And negative 1 plus 4 is positive 3. Okay? So y equals 3. So from z equals 2, we get y is 3. Yeah, we do is by replace this z with this 2. Put it back. Now we have a y3, z2. We put it back here because there are 3 variables. Okay? Now we can find out x. 1 times x is x. Negative 2 times y, that's 3. So negative 2 times 3 right here. And plus 3 times z. 3 plus z is 2. So put 2 here. And here negative 2, 3. Negative 2 times 3 is negative 6. Positive 2 times positive 2 is positive 6. Those two cancel each other. So x equals 4. The way we did right here is called back substitution. Okay, so this, to solve this system, is, you can recall now, is what? We have eliminated these two x's, and then eliminate this y. Make this triangle be empty. Okay, and then we do, that's the first step. After we reach the final step, we do the back substitution. Okay, that will be easy. So here there are 2 ways involved. One is eliminate x and y, and then we do the second step would be back substitution. This way is very powerful. Hopefully you can handle that. Okay. Now there's something new right here. Look. Here variables, we didn't do anything with variables. We only know is that the first column is x, the second column is y, the third column is z. Okay? Now you know, after we reached this place, we know here will be 1 times z is 2. So anyway, the third column is z equals, okay, and then you know after z is the equal sign. So basically we do is we only operate on the coefficients. We didn't do anything with y. Okay. So what we can do here, we like to take all the variables x, y, z away, including the equal sign. That's the important progress. Okay, because we only did is, you know, right here. Now I take this one away. Back substitution away. So I'll put this operation back here. All right. Okay. Please remember that how did we get this place be 0? It's because negative 2x positive 2x cancel each other. It's because negative 2 plus positive 2, you get 0. 0 times x. 0 times x is 0. So that's why we don't write 0 here. Again, first column x, second column y, third column z. But you know, again, if here 0 times x, then we get empty spot, or you may put 0. The reason I repeat is that I'm going to take this x, y, z away, including the equal sign. Okay? But still remember the first column is x, second column is y, third column is z. Okay? I'm ready to do that. So remember, equal sign is also taken away. Equal sign then constant. Constant are on the right hand side of the equal sign. I'm going to take this variable away. Okay? And then I'll put this one back here. Looks like magic. Okay. Now this is the place why we introduce new concept, a matrix. This matrix is called augmented matrix because the constants are involved. Okay? Without constant, all those are the coefficients of x, y, z. That would be called coefficient matrix. All right. You can see right here. This is a new concept, matrix. And then the things we did here are called raw elementary operations. How many kinds of raw elementary operations? There are 3. Look what we did right here. Exchange 2 rows. That's one kind. Very easy. Okay, exchange those 2 becomes those 2. So this is one of the elementary operation. The first one. Second one is raw multiplied by a constant. You see, previously we did the second raw, this one, multiplied by 1/5. Then we got new raw. Okay, so you see right here, the second raw multiplied by 1/5, you got a new raw. Okay, 1 divided by 5 is 1. Negative 10 divided by 5 is negative 2. Negative 5 divided by 5 is negative 1. So the second operation is a raw multiplied by a constant. Okay, that's the second operation. And here, so is the case right here. You see the last one? Okay, raw 3 multiplied by negative 1/2. This one. So we get, negative 1/2 times negative 2 is positive 1. Negative 1/2 times negative 4 is positive 2. So those 2 are the same kind. Those 2. This one here and this one. Now, these 3 are the same. These 3. The one here, the one here, the one here. That's a raw multiplied by a constant and add onto another raw. Apparently, you can see right here is the first raw multiplied by negative 2 and add onto the raw 2, get a new raw 2. So only these 3 kinds of operations. Exchange 2 rows, a raw multiplied by a constant, and a raw multiply a constant, and add onto another row. Not more than 4. You see right here, Those two are the same. Those three are the same. And this is the first one. So with these three elementary operations, then a system of linear equation can be solved. Okay. There is a name for this form, which is called echelon form. Means if there are no empty space right here, that was 0. Okay, you may put 0 here. Okay, because here was 0x, so you don't write. 0 times x is 0, so you don't write. For the matrix, you want to plug in 0 here. Okay, and this form is called echelon form of a matrix. Up to this far, you can use the back substitution. And later on, instead of put x, y, z right here, for each one, you just take it off. Only work on the coefficients. And the way we are doing this is called the matrix way to solve the linear system. Okay? And here there's some new terminologies comes out. Okay. Now, let's see what's left over. It looks like we don't have anything else left over. Okay. So, this one you're going to review that. Now, later on, when we are going to solve this linear system, we will no longer do by elimination. We will only act on the matrix. Okay. Now, look at this example. This example is that ask you to try yourself. Okay? Try yourself, and here is 2x minus 3y equals negative 14. 3y plus z is 3. 5x minus 3z is negative 11. There are three variables, x, y, and z. And then you want to write in this way. Z was not here. That's actually because 0 times z, you got z. You got 0. So you wanted to plug in 0 here. Now here there is no x. That's because 0 times x is 0. So there is no x. And here there is no y. Is because 0 times y is 0. So we didn't write y variable. Now after you get this system, the corresponding augmented matrix is take all the coefficients 2, negative 3, 0 out, constant negative 14 out. Make sure the constants is all the constants are on the right hand side of the equal sign. Okay. And then 0, 3, 1, 3, 0, 3, 1, 3. 5, 0, negative 3, negative 11. So what you want to do is what? You want to try yourself in this case is that you want to make these both be what? 0. Okay? And then you already have a 2, 0 now. You just want to make this one be 0. Okay? Yeah. But you know, when you make this one be 0, this one may not be 0, and then you want to use this one to eliminate that. So that's why to review the first example is important. Okay? Now, after you get this echelon form, you can do the back substitution. Okay? So review this one, do this one yourself by reviewing the first part of the example. Okay? I'll see you next time.